Hello there and welcome to the June 2019 paper. Here we're looking at question 9. So we have f of x equals 2x to the power of a third plus x minus 2/3 to the power of minus 2/3. The finite region bounded by the curve y equals f of x and the line x equals an eighth, and the x-axis and the line x equals 8 is rotated through theta radians around the x-axis to form a solid of revolution. Given that the volume of the solid is 461 over 2 units cubed, use algebraic integration to find the angle theta through which the region is rotated. So, if we want to do 360-degree rotation, it's going to be pi times the integral from 1/8 to 8. And then it's going to be this curve squared here. So 2x to the power of a third plus x minus 2/3 squared dx. We'll work out what this is equal to, and then we'll work out how much of the full 360-degree turn this is. You could effectively think of this as multiplying it by theta over 2 pi. And then this will equal 461 over 2, because theta is how many radians you'll do. 2 pi radians is the full turn, so if it was 2 pi, then this fraction here would just cancel out. So we could probably cancel out the pi's there, and we cancel out the divide by 2's. So actually what we've now got is theta times this integral. And then I'll expand the brackets now, so it's going to be 4x to the 2/3 plus 4 lots of x to the minus a third plus x to the minus 4/3 dx equals 461. Okay, maybe we'll carry this on. So let's now do the integration. So it's going to be theta times the integral of increase the power by 1, so that's now going to be 5 over 3, and then divide by that power, so it's going to be 12 over 5 x to the power of 5 over 3, and then it's going to be plus, increase the power by 1, so it'll now be 2/3, and divide by that new power, so it's going to be 12 over 2 is 6, so x to the 2/3, and then it's going to be minus 3x to the minus third, and then we'll substitute in 8 and minus, so 8 and 1/8 equals 461. Okay, let's now substitute in those boundaries on the upper bound and the lower bound. So 12 over 5 times 8 to the power of 5/3. Let's do that nice and slowly. Type it into the calculator and you get 384 over 5. Then 8 goes into the next substitution area, so that would be 24. And then 8 goes into the last one at the back there, and that would be minus 3 over 2. Then it's going to be minus, and the first one, substitute the 8th in on the bottom, that's going to be 3 over 40. Then the next one, substitute in 8th into the middle one, that would be minus, so that would be plus 3 over 2. And the last one will be minus 6. And all of that will add together to make 461. So let's now simplify all of that together. So theta will multiply by 4149 over 40, and that will equal 461. So let's now times 461 by 40, and then divide it by 4149, and we get theta equals 40 over 9. So there we are, that's the answer for this question here then. So be very careful of your integration, you're substituting into your boundaries. And the key to this question here was at the start, you could have sorted out the theta at the end after working out what the 360 revolution was, but thinking about the revolution as theta over 2 pi, because 2 pi would be 1 revolution, but then if you then cancel the pi's out and then times it by the revolution that you'd like to rotate it round by, and then set it equal to 461 over 2, then you get your final answer there. So there we are, that's the answer to question 9 there. That's worth 8 marks. Let's move on to the final question, question 10.